In this question, we're told that a car rental company is changing its costing model. So it's moving from an initial fixed cost of $25 up to $32. And it's moving from a charge of 25 cents per kilometer to 15 cents a kilometer. So the fixed cost represents the initial value. And the cost per kilometer, the key word is per, represents the rate of change. And what we have to determine is how the graph of the new total cost will be different from the graph of the old total cost. Well, let's go ahead and draw the graph of both of these linear relationships. So our vertical axis is the cost C in dollars, and our horizontal axis is N, or the number of kilometers. And we got that information from here, total cost C and the number of kilometers N. So let's now pick some values for the vertical axis. So maybe we can go up by 10, say that's $10, $20, etc. And we can get a rough idea of what values to pick here by looking at the initial values here. And on the horizontal axis, let's go up by, say, 20 kilometer intervals, 20, 40, etc. And we can get an idea of what values to pick here by looking at the rate of change. And because it's like a decimal 2.5, multiplying by 100 will give us a nice number. So I went up to 100 kilometers and picked some intervals along the way. Okay, let's start with the old total cost. We begin with a $25 fixed cost. Let me start with red, and we'll put that initial value right there. Now let's say that we drove for 100 kilometers. So if it was 25 cents per kilometer, 25 times 100 would give us a cost of $25 for the kilometers. And then the total cost would be the $25 fixed cost plus the $25 kilometer cost, which means the cost after 100 kilometers would be $50. And then let's draw a line between these 2 points. Now let's look at the new total cost line. So here the fixed cost or initial value is $32. So that would be about there. Let's say we also went 100 kilometers here. So 100 times 0.15 would be $15. So the total cost for that trip would be the 32 fixed plus the $15 kilometer charge, which would be $47. Or about there. And let's draw a line through those 2 points. So the yellow line is the new cost, and the red line represents the old cost. So now we have enough information to answer the question here. So the graph of the new total line cost, so we're looking at the yellow line, is it steeper and starting higher on the c-axis? Well, it does start higher, but the graph here is not steeper. The old line has a steeper slope. So we know that that's not the right answer. So is it steeper and starting lower? No, we know it's not steeper, and it doesn't start lower, it starts higher, so we know that that's not the right answer. So is it less steep and starting higher? Well, yes, it is less steep, and it does start higher. So that looks like it's going to be our answer here, but let's verify. Let's look, is it less steep and starting lower? Well, it is less steep, but it doesn't start lower, it starts higher. So that's not the right answer. So we know that the answer is C. But let's not stop there. There's some other things that we can get out of this graph. For example, this point right here is the point where the old cost model and the new cost model are identical. And we can look at the graph and go down to the number of kilometers. So it looks like about 70 kilometers that you will have the old and the new being exactly the same cost. The other thing we can do is we can actually determine the equations of both of these lines. For example, the equation of the old line, total cost would equal the rate of change, which is 0.25, times the number of kilometers in plus the initial value, which is 25. And we could also get the equation for the new cost model. So total cost would be the rate of change, or 0.15, times the number of kilometers plus the fixed value, or the initial cost, of $32. Now the question didn't ask us to come up with this information, but we're just exploring our what we know about linear relations to extend the question. Now if we wanted to know the exact number of kilometers for which the old and the new cost model are identical, we can simply subtract these two equations here. So C minus C is 0, 0.25n minus 0.15n is 0.1n, and 25 minus 32 is negative 7. Now I can add 7 to both sides here. And when I do that, I get 7 equals 0.1n. And then we can just multiply both sides by 10 to get rid of the 0.1, and that would mean that n would equal 70. So that's the exact number of kilometers for which the old costing model equals the new costing model. Again, all this stuff here, they don't ask us in the question, but it's just kind of nice to know and extend the question. So given this information, why do you think the company changed its costing model? Well, we can speculate and say it looks like for distances under 70 kilometers, the new costing model will bring in more revenue. So they've probably done some research and found out that most of the time people rent cars, they don't travel more than 70 kilometers. Another reason might be is that they might have found that maintenance costs are higher for shorter kilometer distances. Therefore, what they want to do is increase the revenue for distances traveled under a certain amount. Another thing we could do here is if we didn't want to draw this graph out here, or the graphs, can I find the answer by just looking at the information here? Well, actually there is a shortcut. We know here that the rate of change goes from 25 cents a kilometer to 15 cents a kilometer. In other words, the rate of change is smaller. Therefore, the new line will be not as steep as the old line. Also, the fixed cost goes from $25 up to $32. Therefore, for the new line, the starting point will be above that of the old line. So we can see the new line will be less steep because the rate of change has gone down, but it will start higher because the fixed cost, or the initial value, is higher. Anyways, there's lots of things that you can do with a question like this, and there you go. We've got our answer of C.